You finish a switch change, close the rack, then realize you need to check another device across the building. The console cable is honest but limited. It reaches only the box in front of you. It also creates a security problem. If someone can plug into that console port, they have a direct path to the CLI. So the real operations question is simple. How do we manage a device when we are not standing beside it? The answer is remote access over the network, normally SSH. Before SSH makes sense though, you need the Cisco idea of lines, logical paths into the command line interface. The console port uses the console line, configured with line con 0. There is only one console line, so one person can use it at a time. It is the local door into the device, and it still needs authentication. You can protect a line with a line password by using password and login, or you can use local user accounts with username admin secret, CCNA, and login local. That distinction matters. Login means check the line password. Login local means check the local username database. In practice, local users with secret are the better habit because each admin can have a separate credential. Logging in does not automatically mean full control. By default, a user lands at privilege level 1, user exec mode. That is the safer, limited prompt where you can run basic show commands but not change the device. To reach privilege level 15, privileged exec mode, you type enable. That step should be protected with enable secret, not the older weak enable password. You can also create a user with a starting privilege level, like username admin privilege 15 secret CCNA, but the exam still expects you to understand why the enable secret exists. It protects the jump from looking to changing. A router usually has IP addresses on routed interfaces, so remote management has an obvious destination. A layer 2 switch is different. It forwards frames, but it still needs one IP address, so you can SSH to the switch itself. That management address lives on an SVI, a switch virtual interface. You enter interface VLAN 1, or better, a dedicated management VLAN, assign an IP address, and bring it up. If the switch must reach a device outside its local subnet, add IP default-gateway, pointing at the router for that VLAN. Best practice is to keep management traffic away from normal user traffic, with a management VLAN. On routers, a loopback interface is often preferred for management because it is logical and stable. It stays up as long as the router has any working path, instead of depending on one physical port. Telnet is the warning story. It gives remote CLI access, but it sends everything in clear text: username, password, commands, output. Anyone who captures the traffic can read it. Telnet uses TCP port 23, and that number is exam fuel. Remote CLI sessions use VTY lines, short for virtual teletype. On many iOS devices, you configure them with line VTY 015, which gives 16 possible remote sessions. The VTY lines are where you decide who can log in and which remote protocol is allowed. A Telnet-only example might use local users with login local, then transport input Telnet under the VTY lines. You may also restrict the source addresses with an ACL and apply it to the VTY with access-class 10 in. Remember the placement. Access-class goes on the VTY line. Interface ACLs use IP access-group. SSH solves the Telnet problem by keeping the same remote management idea but encrypting the session. It uses TCP port 22. The user still connects to the VTY lines, but the traffic is protected instead of readable on the wire. SSH has one setup dependency that catches people. RSA keys. iOS needs a hostname and a domain name, so it can build the device FQDN used for the key pair. That means hostname SW1, then IP domain -nameexample.com, then crypto key generate RSA. When iOS asks for modulus size, use 2048 bits. It is the practical, secure answer and the CCNA-friendly answer. After the keys exist, iOS may show SSH version 1.99, which does not mean a special new version. It means the device can accept both SSH v1 and SSH v2. Lock it down with IP SSH version 2. Now put the pieces together like you would on a real switch. First, protect privileged mode with enable secret. Next, create a local admin account with username admin secret CCNA or include privilege 15 if that account should land directly in privileged exec. Then, give the switch a management IP on the management VLAN SVI and configure IP default-gateway if the admin station is off subnet. Set the hostname and domain name. Generate RSA keys with a 248-bit modulus and force SSH version 2. Finally, enter line VTY 0 through 15. Use login local, set an idle timeout, allow only SSH with transport input SSH, and apply a source restriction with access-class 10. The decision is the whole lesson. Remote access is useful only when the line, user database, privilege path, management address, encryption, and VTY ACL all agree. Console access is line con 0. Remote access is VTY, commonly line VTY 015. Login checks a line password. Login local checks local usernames. Use username secret, not a plain password, and protect privileged exec with enable secret. A layer 2 switch needs a management SVI plus IP default-gateway. Use a management VLAN when possible, and use router loopbacks for stable management addresses. Telnet is clear text on TCP/23. SSH is encrypted on TCP/22. Requires hostname, domain name, and RSA keys. Choose 2048-bit modulus. Expect SSH v1.99 as the default mixed mode, and force secure-only access with IP SSH version 2 plus transport input SSH. To limit who can reach the VTY lines, use access-class.